Today's discussion on important exemplar from relation and then understand functions by easy definition with the help of arrow diagram. After that, we shall take the question 1 from exercise 2.1. Okay. Find the domain and range of the relation R is equal to xy such that x square plus y square is equal to 25, where x and y belong to the set of whole numbers. You see your solution R is equal to ordered where xy such that x square plus y square is equal to 25, whereas x and y must belong to the set of whole numbers w. I am converting this relation into other format. C equal to xy such that y is equal to plus minus root over 25 minus x square, where xy belongs to w. But see that I am taking plus only because this condition is x and y both must come from that set. Okay, now we can start. X is equal to 0 implies y is equal to root over 25 minus 0 square equal to root 25 equal to 5, which belongs to w. Similarly, you put x equal to 1, 2, 3, 4, 5, 6, etc. and go to see the corresponding elements. Then taking x equal to 6, we see that y is equal to, this is coming root over minus 11, which is not a real number also. Okay, and hence does not belong to here. And further taking x is meaningless because it will be coming all negative numbers. So up to here it is finished. Therefore, dr is equal to 0, 3, 4 and 5, and range of the relation is equal to 0, 3, 4, 5. This is the answer. This format is somewhat longer but very easy to be understood by the beginners. And also one more benefit that while you are going to function to find the range and domain, you will see that this type of formats are often coming. Okay, so it is also a little bit practice here. So now we are going to understand what is function. A function is actually a relation with some special characteristics, and here lies the significance of learning the relation, implying to understand the function. Okay, so let us understand by certain definitions. There are different definitions of functions from different textbooks. Read the two definitions given in the ncert book. First one is a relation f from a set A to a set B is said to be a function if every element of set A has one and only one image in set B. And second one is a function f is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no two distinct ordered pairs in f have the same first element. Actually, both the definitions are difficult to understand by the beginners. If there is a confusion, then please you can follow this easy definition which I have made with my own language with the same summary. So read this one also here. A relation from x to y is said to be a function f from x to y if and only if condition 1 that x is the domain of the relation, and second condition is that any element of x is found to be related to any single element in y. And let us understand this with the help of arrow diagrams. If you understand the arrow diagram, then you think that you have learned function thoroughly. See, I have drawn 4 arrow diagrams which are for relations. So first one is x1, one single element has gone there, single element x3 has gone there, but one element x2 is not connected there. But by definition, for first condition is that the whole set should be domain. This means that all of the elements must be engaged. So it is one element remaining, so it is not a function. Okay. Here we come to justify the two conditions given in the definition. First condition that x is the domain of the relation. So it is exactly that, okay, all elements have been connected. And which way it is connected? Now let us justify the second condition. So second condition says that any element of x is found to be related to any single element. That element can be any element but a single element. x1 to y1, x2 to y2 and x3 to y3. It is very nicely understood that two conditions have been satisfied. This relation R2 can be called a function F2. So come to R3 relation. X1, X2, X3, we see that all of them are connected. Okay. So first condition is satisfied. Now justify the second condition. We see that X2 has gone to Y1 as well as to Y3. It is having two different single elements. So it has violated the second rule. Come to R4 relation. We see that X1, X2, X3 all are. So first condition satisfied. And then second condition you take individually. X1 has gone to Y2. The second condition states that any element of X is found to be connected to any single element. So for them it is respectively single element. Now to understand what is the confusion in NCERT definition. In NCERT first definition it is said that every element of A has only one image in set Y. So here is the confusion. So most of students think like that. Probably it is the only one element to which all the elements must fall always. But that is not the concept actually. Even though the definition tries to say that any unique element. And in second definition also it is said that no two distinct pairs have the same past element. That is also difficult to understand. Okay, so when you are habituated well about the functions in higher classes, then only you will understand very easily. Okay, so I hope that the last definition, easy definition, you have understood. And domain and range of functions are similarly denoted by the f is made suffix and range is fixed. Okay, domain and range functions are very important actually. Unless you understand right now, actually you will suffer throughout the life in different disciplines of mathematics and physics. Now we are going to take the first question, exercise 2.1, and we shall understand it with the help of arrow diagrams. Which of the following relations are functions? Give reasons. If it is a function, find its domain and range. All are given in roster form. So by seeing the roster form, you cannot immediately decide what it is actually. But if you draw the arrow diagram, then it will be very easy. Okay, solution I'm taking. This is the relation given in terms of roster form. Okay, so you have to say whether it is a function or not. If you say function, then what reason you must support your answer. So 2 to 1, 5 to 1. See, it is a nice thing that I took in my last relation figure. Okay. We denote it by A and B so that in case of any mentioning of the set, actually, briefly we can mention by name. Given relation is a function since A is the domain and any element of A is found to be related to a single element in B. Okay, even though it is one for all of them, no problem, but for any individual element we see that this is the thing found to be related to a single element. Okay, now what is the domain and range? See, df is equal to 2, 5, 8, 11, 14 and 17, and range is equal to only 1. Okay, taking the second one, this time also I write A and B. 2, 4, 6, 8, 10, 12, all inputs 70, 10 here in the set A, and all output 1, 2, 3, 4, 5, 6, 7, 10 in the output set. How the relation? Obviously 2, 1, 4, 2. See that obviously it is a function. All have been engaged. First condition. Second condition, that each of the elements is having a single element in B, whatever it is. Given relation is a function seen any element of A is found to be related to a single element in B. df is equal to 2, 4, 6, 8, 10, 12, and rf is equal to 1, 2, 3, 4, 5, 6. This is the roster form, the third portion. So I have converted into arrow diagrams. Okay. So see that 1 and 2 input set elements are connected here. First condition satisfied. But second condition violated. See, 1 is connected here to 3 and 5, which are two different single elements. Given relation is not a function since one element of A is getting two different images in B. And hence no question of finding the dominant range also. This is the answer for this third part. Today I am finishing here, and next day we shall start again from function basics. What are the important shortcut terminologies relating to function which you will get abundantly? And on that day we shall start what are the kinds of functions, very important, and then we shall go to solve the range and domain of those functions.